Alright, hello everybody, welcome to the week 24 test key. Let's go ahead and get started. So question number 1, it says historically, a given day at the beginning of March in upstate New York has an 18% chance of snow and a 12% chance of rain. If there's a 4% chance it will rain and snow, so this is a 4% chance of both, what is the following probability that a given day would have either rain or snow? So I always have to take the probability of one, so we'll say 18%, plus the probability of the other one, which is 12%, and I'll add these together. And then I have to subtract the probability of both, which is 4%, and that will give me my overall probability. So 18 plus 12 is 30, minus 4 is 26, so that is equal to 26%. That's the probability that it will either have rain or snow. Number 2 says compare the quantity in column A with the quantity in column B. So first of all, we have the probability of A given B, and then we have the probability of B given A. So to find the probability of A given B, I would have to do the probability of A and B divided by the probability of B. So this would be the probability of A given B. So I will go ahead and draw an arrow there and find the probability of B given A. That would be the probability of A and B over the probability of A. So let's figure this out. So the first one is going to be simplified to 0.27 divided by the probability of B, which is 0.4. And this next one is going to be 0.27 divided by 0.07. And so now I'm going to pull up a calculator. Wabbit. Okay. Here we go. So the first one's going to be 0.27 divided by 0.4, which gives me 0.675. And then the other one, I am dividing it not by 0.07, oops, I'm just going to be dividing it by 0.7. So let's use the eraser there. I just wrote that wrong. Divided by 0.7. So 0.27 divided by 0.7 gives me 0.386, I'll say. And so that means the probability here is going to be greater. So that is the probability of A given B. Quantity in column A is greater. All right, number 3. It's asking me for f of g of 3. So the first thing I need to do is find g of 3. So that would be x cubed minus 2, except instead of x, I'm going to be plugging in 3 squared minus 2, which is going to be equal to 9 minus 2, which is 7. And then I'm going to have to take that result and plug it into f. So I'm doing f of 7 now, and that will be equal to negative 2 times 7 plus 7, which is going to be equal to negative 2 times 7 is negative 14, plus 7 is negative 7. And that'll be number 1. All right. So the results of a survey of the student body of Central High School about television viewing preferences are shown below. So the survey is shown below. Are the events student is male and students prefer reality series independent or dependent of each other? Or are they independent of each other? Justify your answer is actually what it asks. So I'm just going to need to take a look and see if there's any dependence on being male on preferring reality series. So I'm going to want to take a look at the total. So first of all, I'm going to look at totals. So the total, there are 490 students. That's my denominator. I'm just going to sort of divide it like this. And of those 490 students, 180 prefer reality series. So I'll say 180 reality fans. So let's go ahead and get that as a decimal. So 180 divided by 490. So this is like about 37% of all students prefer reality TV. All right, now let's look at the males. So there are total 230 males, and of those 230 males, 70 prefer reality. So now we'll find that. So 70 out of 230 is only 30%. So 30% of men prefer reality TV. So we will say because this probability and this probability are different, we will say these events are not independent. And I'll say that's because gender, or being male, affects the likelihood that a student prefers reality TV. All right, number 5. Month of March has 31 days in it. In New York, it has days where it snows, rains, and does both. There's a breakdown in the Venn diagram. So based on the diagram, are the events of having snow and rain dependent or independent? So we'll have to take a look at the chances. So the chances that it will snow, let's see, I need to think about this. So I need to be comparing some sort of like probabilities here to see if they're independent or dependent. Let's see. Okay, I'm going to think about it for a second. I'll be right back. Okay, so I think what I'm going to have to do is I'm going to have to figure out the probability of snow given rain and compare it to just the probability of snow. And then I'm going to find the probability of rain given snow and just compare that to the probability of rain. So first let's figure out the probability of rain and the probability of snow. So the probability of rain, I'm going to do in a little box down here. So the probability of rain is going to be 8 plus 5, which is going to be 13 out of the 31 days had rain. And that's equal to 13 out of 31. So that would be about 42% of days had rain. So the probability of rain is about 42%. So I'll set that off to the side. Okay, now let's figure out the probability of snow. So the probability of snow appears to be 8 days out of the 31, because I've got 3 days with just snow and 5 with both. So 8 out of 31 is about 26% of days it snowed. All right, now we will figure out the probability of snow given rain and rain given snow. I should use a different color. Oh well, I'll do this in green too. So the probability of snow given rain. So now we just care about the days when it rains. So there are 13 days where it rains, and of those days where it rains, on 5 of those days it also snowed. So that would be 5 out of 13. So that's about 38%. And then there's the probability of rain given snow. So now I just care about the days when it snows. So the days when it snows, there are only 8 of them. And of those 8 days, it rained also on 5 of them. So that's clearly a majority of those days. 5 out of 8 is going to be 0.625, or 63%, we'll say. Okay, so all of these probabilities are different. So I want to make comparisons here, right? I want to see the probability of snow / rain versus snow. So I know that the probability of snow given rain, I should say, is 63%. Or excuse me, that's the probability of rain given snow. The probability of snow given rain, my bad, is 38%. So that means that 38%. So that means if it's already raining, there's a 38% chance it's going to snow at some point, whereas the probability of it snowing on any given day is 26%. So if it's raining, it actually makes it more likely that it'll snow later. And then the probability of rain given snow is 63%. So if it is already snowing, there's a pretty darn good chance it's going to rain, versus the probability of rain is just 42%. So we're going to say that these events are definitely dependent. And I have a computer. I'm going to type this. I just realized that'll be so much easier. Right, so let's put this in. So these events are dependent. If it snows, it is more likely to rain. And hello, if it rains, it is more likely to snow. All right, having a lot of guest appearances in our video here. Continuing along. Number 6, it says condense into one logarithm. I feel like maybe I should pause this. I'm just going to keep it rolling. They'll come back through again. It's going to be fine. All right, so first of all, anytime I see a number in front like this, I know it can become an exponent. So I'm going to do that. So this becomes log base 2 of x to the 3rd power minus log base 2 of x plus 3 raised to the 4th power plus log base 2 of y. Then I know that subtraction can become division and addition can be multiplication, so I can rewrite this as log base 2 of x to the 3rd divided by, and then I'm going to have log base 2 of, let's see, yeah, I'm going to say log base 2 of x plus 3 to the 4th plus log base 2 of y. And then I can again rewrite addition as multiplication, so I get log base 2 of x to the 3rd over log base 2 of x plus 2 to the 4th times y. And there, I think we have it. So it's all in one logarithm. I no longer have addition or subtraction. I've replaced them with multiplication and division. All right, next up, is this even, odd, or neither? So the first thing I need to know is if something is even, and I'll go ahead and type it. If a function is even, it can be reflected across the y-axis and remain unchanged. This cannot, so it is not even. If a function is odd, it can be rotated 180 degrees and remain unchanged. This function cannot, so it is not odd. This function is neither even nor odd. It's not even, it's not odd. Let's make sure that's right, because I'm just imagining here, right? If I reflected this over the y-axis, or it would look something like that, and that's not the same function. And if I rotated it upside down, it would look something like that, and that's not the same function. So it's not even, it's not odd. All right. Geometric series. So it says it has a first term of 32 and a final term of -1/4 and a common ratio of 1/2. the value of this series is. So I want to find the sum of a geometric series. I'm going to want to check my reference sheet. So I've got it up at the bottom of our test here. So I'm just going to grab this reference sheet here and I'm going to paste it into our slide just so I can see it a little more clearly. I've got it now. Okay. So the sum of a geometric series looks like it is right here. This is the formula I'm going to want to use. So it's going to be A1. So it says the first term is 32 minus A1 times the common ratio, which is negative 1/2, times the number of terms. So this is the part where I actually have to do a little bit of math. So, gosh, I don't know. I think I'm just going to make a list. So in this case, I know A1 is 32. A2, my common ratio is, negative 1/2. So I'm always multiplying by negative 1/2. So I'm going to use a calculator and I'm going to do this. I'm going to shut the door. It's getting kind of loud. I'll be right back. Okay, here we go. So first of all, my first term is 32, and I'm going to multiply by my common ratio. Actually, to make my life easier, I'm just going to take my common ratio, which is negative 1/2. Yeah, I'm going to take negative 1/2 and I'm going to store it into a variable. So I'm going to do negative 1 over 2, do it as a fraction like this, so all my answers will be fractions. So I'm taking negative 1/2 and I'm going to store it in the variable x. Okay, so now what I'm going to do is my first term is 32, and I'm going to multiply that by my common ratio, which gives me A2 of negative 16, A3. So I'm taking that answer and I'm going to multiply it by my common ratio again, which will give me a positive 8. Then I take that and I multiply it by my common ratio, so that'll be, again, I take my answer and I'm multiplying it by my common ratio. So now it's negative 4. A5, I'm taking it, I'm multiplying it by my common ratio, it gives me positive 2 times my common ratio. Should give me a negative 1, it does. Times my common ratio gives me 1/2, which means that my 8th term here should give me negative 1/4, times my common ratio again gives me negative 1/4. Hey, so that means that this is going to have 8 terms. So I know that n equals 8 because it is my 8th term. So that means I have 8 terms in my series, and then it's going to be 1 minus my common ratio, which is negative 1/2. I also could find the sum just by adding up all of these terms together. So I've got a lot of options here, actually. And maybe I could even check myself that way, although I don't think I will just for the sake of time. So I have 32 minus 32 times my common ratio of negative 1/2. All of this is being raised, or just the negative 1/2 is being raised to the 8th power, and it's going to be over 1 minus my common ratio, which again is negative 1 over 2. And this gives me 21.25. Ooh, and that is right there. That's the sum of my series. And if I add it up, it kind of makes sense because I've got 32 and negative 16, so that would add up to positive 16, plus 8 is 24, minus 4 is 20, plus 2 is 22, minus 1 is 21, plus 1/2 would be like 21.5, and then minus a quarter would be 21.25. Yeah, totally, 21.25. Okay. So now it's saying this expression is equivalent to what? So first of all, I know whenever I have a negative exponent, it could be rewritten as a positive exponent, but in the denominator. So that's my first step. Then I know that this is a root, and the 2 is going to be an exponent. So I'm going to have 1 over, it's going to be a cube root, and my exponent is going to be a 2. So that looks like, well, it can't be that because that's not a fraction. It can't be that because it's not a fraction. This is the only one with a cube root, and my exponent is in fact a 2, so we are in really good shape. Answer choice should be 2. Number 10, it says algebraically prove that this is equal to this, where x is not equal to 2. So the way I should do this is I should just be manipulating one side of the equation and making it match up. So what I'm noticing, hey Jose, come on in. What I have here is that I've got x to the third plus 9 over x to the third plus 8 is equal to 1, and I'm going to write it as 1 over 1 just to make my life a little easier later, plus 1 over x to the third plus 8. Okay, so to do a proof, I'm not going to want to touch this side. I want to just keep this side exactly as it is, and I'm going to manipulate this side and try to get this side to look like this side algebraically. So in order to do that, it looks like I'm going to need a common denominator. So it's going to have to become x to the third plus 8 and x to the third plus 8. Okay, so this now I can kind of ignore my denominators, but I won't actually because I'm not solving an equation. I'm going to distribute. So this will be equal to x to the third plus 8 times 1, which is just x to the third plus 8, plus 1 over common denominator x to the third plus 8. And then this is going to become x to the third plus, why did I write an 8? I don't even know why I did that. This is going to become x to the third plus 9 over x to the third plus 8. And there I have it. This and this are identical. I have algebraically proven that this half is the same as that half. All right. Convert to degrees. So I've got pi over 4 radians, and I want to multiply that to convert it to degrees. So I should have the pi on the bottom, so it'll cancel, and 180 degrees on top. Pi cancels with pi, and then I get 180 degrees divided by 4, which is going to be 45 degrees. Pi over 4 is 45 degrees. Convert 65 degrees to radians. So 65 degrees, and I'm going to multiply that, put it over 1, and multiply that. I have 180 degrees on the bottom, and I'll have pi radians on the top. So now I'm in radian mode. Cancels out, and I get 65 pi over 180. So 65 over 180, I'll just go ahead and let my calculator reduce that, even though I'd probably be very capable of doing it on my own. Feeling lazy. All right, so I get 13 over 36. So I get that equal to 13 pi over 36, and that's my simplest fraction. If you were to do it as a decimal, 13 pi is that divided by 36 gives me approximately, and this is of course radians, approximately 1.13 radians if you were to give it as a decimal, which we didn't ask. We asked for simplest form, but I just want to put that there as well. Okay, 12. It says we want to solve for when this function is less than 0. So first of all, I know this is going to be some sort of a quadratic function, so it's going to look like this, and I want to know when it is less than 0. So it'll be less than 0 in between my two zeros, so down here. I'm thinking I'm going to want to shade inside. First, though, to be sure, I'm going to put it on a number line. So first I've got to factor it before I can even do that. I want to know when it's equal to 0. So I'm looking for two numbers that add to -7 and multiply to 10. So 5 and 2 multiply to 10. -5 and -2 would multiply, or add to 7 rather. So x minus 5 and x minus 2 equals 0. So my solutions are going to be x equals 5 and x equals 2. So I'll put a 2 on the number line. I'll put a 5 on the number line. That means my roots are 2 and 5. I'm going to do open circles, because it's just a less than sign, not an equal to sign. And again, I'm pretty sure I'm going to be shading in the middle because it's a less than, and it's going to drop under the x-axis. But just to be sure, I can test a point that's in the middle. So in between 2 and 5 would be like, say, I don't know, 3. So I'll test the point 3. So I've got 3 squared minus 7 times 3 plus 10 is less than 0. So 3 squared is 9 minus 21 plus 10 is less than 0. 9 minus 21 is going to be negative 12 plus 10 is less than 0. This will be negative 2 is less than 0. This is true, so I would shade inside on top of the 3. So I can say for sure my solution set is going to be the values of x that are in between 2 and 5, with neither being included. I could also write it that x has to be in between 2 and 5 this way, or of course I can put it on a number line like this. So you have a lot of different ways you'd express this solution set. 13 says we've got a recursively defined sequence. So it says that f of 0 is 2. Interesting. So I know that f of 0 is equal to 2. Then I know that the next term is the previous term times, or I should say the current term times negative 2 plus 3. So yeah, we'll keep going. So that means the first term of the series is going to be negative 2 times the previous term plus 3. Negative 2 times 2 is negative 4 plus 3 is negative 1. The second term here is going to be negative 2 times the previous term, which in this case is negative 1, plus 3. So this would be negative 2 times negative 1, which is positive 2, plus 3, which is 5. Woo. Okay, negative 2. Great. Okay. 14. The 8th and 10th terms of a sequence are 64 and 100. If the sequence is either arithmetic or geometric, the 9th term cannot be what? Okay, so 8th and 10th terms. So if it's an arithmetic series, it means I'm always adding the same thing, and if it's a geometric, it means I'm always multiplying by the same thing. So this is the 8th, this would be the 9th, this would be the 10th. So if it's an arithmetic series, I'm going from 64 up to 100, and the term in the middle would be my midpoint, so I can find the average of the two. 64 plus 100 divided by 2. So if it's arithmetic, I'm expecting it to be 82. It will be equal to 82. So it says it cannot be. So it could be 82, so that's out. Now I have to think about if it's geometric, what my common ratio could be. So I would need to see, let's see. I think the easiest way to do it would just be to check. So let's imagine that this middle term was 80. That means my common ratio would be 80 divided by 64, which would be 1.25. So then I would be going from 64, so that means I'm doing 64 times 1.25, which gives me 80, and then I'm taking that and I'm multiplying it by 1.25, which would give me 100. So I know that if it's geometric, it could be 80, because this would have a common ratio of 1.25. It could also be negative 80, I'm pretty sure, if my common ratio were negative 1.25. So if I did 64 times negative 1.25, that would give me negative 80 times another negative 1.25. That'll give me a positive 100 again, so that is out because this would be a common ratio of equal to negative 1.25, which means that the only one it could not be would be negative 82. A geometric series would not have that. And that's it for the test. Well, I hope it went really well for everybody. See you guys soon.